All right, welcome. We are going to work on 2.2, increasing, decreasing, and piecewise functions and some of their applications. This is part 1. I'm not sure how many parts we'll have, but we'll get started. Okay, so let's go to our draw. All right, so for linear functions, we have 3 different kinds. Well, 4 technically. We have 4 different kinds. One is increasing, one is decreasing, and one is constant over the entire domain. And then you have vertical line. Okay, so you have horizontal, vertical, and you have increasing and decreasing. So let me go ahead and we'll do a little bit with that. All right, so, and I do want to point out that for nonlinear functions, this is a different set of information as well. They can have more than one direction. Lines, if you recall, only go in one direction. They only have one feature. All right, so here I'm going to have a line that is decreasing here as soon as I can get this to move. So this is a decreasing line. It's decreasing because it goes downhill. All right, so that's a decreasing line. Here I am going to have a increasing function. This is an increasing function because it's going uphill, right? This is an increasing line. And then here I'm actually going to do a duplicate of this so we can have our horizontal and we can have our vertical. So here is my vertical line. There's vertical. And then my horizontal or constant, that is going to be that did not work as it was supposed to. There we go. Now, technology is wonderful when it works. So I am going to have to tweak this a bit. All right. And so this would be a case of a constant line. Okay, it's going to just go straight across. I am not going to spend a whole lot more time trying to adjust that, but you can kind of get the idea. All right, so you've got this horizontal. You've got a horizontal. You've got a vertical. You've got an increasing, and you have a decreasing. So we're going to talk more about what that looks like as far as our our functions that are not linear, but for the moment let's go ahead and I'm going to label these. So this is increasing because it's going uphill. This is a decreasing. This, of course, would be our horizontal. That's an H, not an N, horizontal. And here's our vertical, right? So this one is going to be, let's see here. Yeah, let's see, I'm going to get over here. So this is going to be our vertical. Now, it happens when I'm trying to do things upside down. It doesn't quite work the way I would expect. Alright, so this is vertical. I'm not going to even try and I'm not going to fuss with it more. All right, so vertical. That's the one. And I'm going to just go erase this little mess here. Okay, so we've got our 4 basic types. Horizontal, vertical, are increasing and decreasing. So informally, a function is increasing when the input is increasing and the value of the output is also increasing. So if you take a look here, going back to our picture, right, our graph, you can see as my x values increase, right, so my input is increasing, the value of the output is also increasing, right? So as I go along, these are all going to be higher values on my y-axis. All right. For decreasing, when the input is increasing, right, our x value is increasing, the output is going to be decreasing. If you take a look, that's exactly what happens as we're going from left to right here. This y value gets smaller and smaller, or lower and lower, right? And then our horizontal, it's the same. It stays the same regardless, right? All right, so more formally, this is the way we would say it academically. This is conceptually, here's the academic piece of it. A function f is said to be increasing on an open interval I if for all a and b, where a is less than b, it implies that f of a is also less than b. Okay? So what we're saying is for my inputs, the smaller my inputs, the smaller my outputs for my y. Okay? A function is said to be decreasing on an open interval I if for all a and b, where a is less than b, it implies that f of a is greater than f of b. Okay, so this is saying that as you go bigger, your y value, or your output value, is going to get smaller. A function is said to be a constant on an open interval I if for all a and b, a less than b implies that f of a equals f of b. All right, and so I'm going to actually do a function here that is not a line. I'm going to break it apart into little pieces and we'll go from there. Okay, so let's take a look. I want to do a little section of this. So that's one section. And then let's say right here's our maximum. And then right here's our minimum. And let's say here we're going constant again. So we're going to break this apart, and I want to talk about the different possibilities here. So here I have a constant. It's flat, right? So I'm going to call that a constant. Oops. Sorry about that. I meant to do this one. So constant here and a constant here, right? Those are both flat. All right, so increasing, we're going to have something that is going up, right? As the x values get bigger, the y values also increase. All right, so this is an increasing, right? This is increasing right here. And if you take a look at it, this is also increasing, right? So those two pieces are increasing. And here is a decreasing. Right? Because as my x values get bigger, my y values are decreasing. Right? They're getting smaller. So it doesn't seem like it's too terribly difficult. People can get confused. I'm going to hit a couple highlights here, and I've kind of mentioned them already, but I want to we'll label them and then we'll go back and talk about specifics about what they are. All right, so here I have a turning point, right? This is where it stops being constant and begins to increase. And then here I have a maximum where it goes from increasing to decreasing. This is the point where it changes direction. Here is also a vertex that you're going to need. This is going to be a minimum, right? A minimum, because this is going to be the lowest point here on this curve. This is the point where it changes from being decreasing to becoming increasing. All right, and we've got our x-axis, right? This is going to be our x-axis. This is our x-intercept. Here we're going to have a y, or yeah, I'm sorry, that was our y-intercept. Here's our x-intercept. Here's another x-intercept, right? So here you're going to have all of these different intercepts. Here's my constants. Here's my increasing and my increasing here and a decreasing here, right? Maximum and minimum. So let me go ahead and we'll talk a little more about what those things are. I'm also going to give you the shorthand for some of these things. So a max is our shortcut for a maximum, and a min is our shortcut for a minimum. All right. So our relative maximums and minimums. Now relative is kind of over a specific range. If we're talking maximum or minimum, in general, the maximum is going to be the highest point, okay? The highest point. But if I were to say to you, I am interested in the maximum from here over, right, on my x's, right? This is the beginning place, right? I'm not going to look anything to the left of this. So this is my relative, right? This is still going to be my minimum, right? This is still going to be my minimum. And then here is going to be my relative maximum, because that's as high as it goes, right? It doesn't go any higher than this. So our relative maximum. All right. As we go along here, when we talk about these turning points where it goes from being increasing to decreasing or decreasing to increasing, those are also called vertex. And to have more than one of them is called a vertices. It's called vertices. That's the plural of vertex. Okay? And vertices is spelled V-E-R-T-I-C-E-S. Oops, sorry about that. So our minimum and our maximum occur when the specific intervals, you're looking over those and you find the highest or lowest point over that interval. Okay, so you can say a minimum is a vertex, you can say a maximum is a vertex, min and max, you can use that shorthand. Relative maxima is plural, minima is also plural, right? So you can have more than one. So that gives you a bunch of vocabulary there, and hopefully that will help things make some sense. All right, so here's an application. All right, we're going to talk a little bit about business. We're going to talk about, so this is kind of abstract, and then the next one we're going to do will be a lot more concrete. So actually, let me stop here and I'll come back with my examples.